The idea is to do a short presentation of each participant and the project they are carrying nowadays. So we are going to start with Xavier Gamisans, who is a PhD in chemical engineering with about 30 years experience, and currently he's a full professor in Polytechnic of Catalonia. He has more than 150 scientific contributions in the fields of knowledge of gas and other biological treatments and smart sustainable resources. Currently, he is working in the LIFE project BioGasNet with the objective of cleaning with microorganisms hydrogen sulfide and biogas produced in landfills. Just to start with a question, what is the best basis of the technology you are applying in this project, Javier?
Good morning, everyone. And first of all, I would like to say thank you very much again to this consortium of which is running the Life Digestion 2.0 for inviting me to this webinar. I think this is the third or fourth time I'm participating in your events. You are very, very active, and I'm really proud to be here again. So yeah, as you said, currently I'm the coordinator of the LIFE BioGasNet project. This project started in 2019, and we are at the end, almost at the end of the project. But in fact, it finished next March 2024. So yeah, we have gained a lot of experience in a technology where we are trying to demonstrate a new technology for biogas desulfurization. We are not involved in biogas production. We are involved in biogas desulfurization. So this means we are trying to remove hydrogen sulfide, but with a new process based in what is called the anoxic autotrophic desulfurization. Basically, this is a biological, low-cost, and environmentally friendly process that will substitute the conventional physical chemical processes for H2S removal from biogas. So our objective basically is to boost the use of biogas in different sectors. We have been testing the technology in a landfill in Cadiz for 1 year, and currently the prototype is being tested in Athens, in a very, very large landfill located at the outskirts of Athens. And yeah, I think we have a very, very good technology that has paid really huge attention from different stakeholders right now. So more or less, this is the basis of the project.
Thanks, Xavier. The next speaker is Manuel Hidalgo, who is a PhD in chemistry and currently is full professor for analytical chemistry in Girona University and leads the research group Environmental Analytical Chemistry. She has co-authored more than 120 research papers in the areas of analytical chemistry, separation, and environmental science. Her research interests include sample treatment methodologies, chromatography techniques, atomic spectrometry, and the mobility and fate of contaminants in the environment. Here, she's presenting the project LIFE BioGasNet H2O, and it's the demonstrative project whose main objective is to implement an eco-efficient tertiary wastewater treatment in a system based on nature. What is the technology you are using in the project, Manuela?
Well, the performance of the technology mostly relies on DARNIA, which these organisms are filter feeders capable of injecting particles smaller than 30 microns, and which include bacteria. And there is an additional contribution of the biofilm that develops in certain areas of the reactor that contributes to the polishing of the effluent in terms of nutrients, basically. And in this sense, the design of the reactor and operation conditions favors the settlement of the larger particles and the growth of biofilm in lamellas inside the reactors. This technology was developed in a previous Horizon 2020 project at a smaller scale, treating 1.5 cubic meter water per day. And in the present project, the technology is upscale and the operating conditions will be optimized to treat up to 200 cubic meters a day in Spain, and up to 50 cubic meters in Greece, which are the two demo sites that we have in the project. One in Spain, in Catalonia, near Girona, and another one in Antissa, in the Lesbos island in Greece, that are two water-stressed regions of the Mediterranean area.
Thank you, Manuela. Next speakers, they are joined for the same project is Victoria Puchol, who is PhD in chemistry, and since 2013, he's working as R&D technician in Genealogía, whose mission is a company whose mission is to create an ethical textile industry, sustainable and eco-efficiency. On the other hand, Oscar Calvo is material and chemical engineer, working at ITES since 2005 and with more than 15 years of experience managing regional, national, and European projects. Technical skill on textile industry includes coating and finishing technology and their processes. They are here for presenting LIFE ANHIDRA that reuse water in textile industry for the reduction of about 92% in water use. How are you going to achieve this ambitious project objective of the project of reduction in water use in 92% and in wastewater production in 98%?
Okay, first of all, thanks to the organization, and Carlos, thanks for your introduction. The project Life ANHIDRA is based on the first system for regenerating and reducing the industrial water use in washing finishing process for jeans production. As you know, the textile industry has a lot of problems with water and is the responsible for the 20% of the water pollution in the world. Only for the jeans production, you need for each pair of jeans, you need 100 liters of water. And this, for the best-selling garment in the world, is the jean, is necessary 500 million of meter cubics of water for the production of jeans. In this context, we developed the Life ANHIDRA, and the main object is hydrating the textile industry using a closed water regenerator system, working continuously and directly connected with the washing machines where the finishing of jeans are performed. ANHIDRA will have an important and positive impact on environment because 28% of reduction of wastewater discharge will be possible. The consortium is formed by Genealogía as ANHIDRA technology manufacturers and coordinators of the project. ITEX, as textile specialist, is a technological research center. This is the reason that Oscar is in the room with me. And a Portuguese company, Portuguese textile company, that acts as the demonstration plant for the technology. Okay. And and the most important of the project is that it's a demonstration project focused on reduction of the water consumption in the jeans production, and using a unique system that works in situ in the industrial plant. To end, the Life ANHIDRA is a close-to-market solution, and the final and most important objective is to put in the market this equipment, mainly for garment finishing industry, and if possible, for other textile industries or in other industries if possible. Okay, that's all. Thank you very much.
Thank you, Victoria. So we have a quick question, Victoria. The only demonstration plant is in Portugal, then?
Yes.
There's not in Spain. Nice.
Yes, the unique demonstration plant because it's a big plant, okay? And in Spain, for finishing garment, we have, it's a pity, but we have not a lot of companies that make finishing. And in this company in Portugal has a medium production, and it's very important to test in medium production or production, this technology.
Well, I'm going to ask some questions just to have more information about this project. This question is going to Manuela. Emerging pollutants is an increasing concern in the European Union, both for its impact in the environment and also for the development of efficient and reliable technology for the removal. In this sense, what is the contribution of the project to this issue?
Okay, our projects aim at the improvement of wastewater quality, of course, regarding nutrients, and by the goal is to reduce about at least 50%, and also microbiological parameters. But most of the focus of the projects is also placed on emerging contaminants, of the removal of emerging pollutants, specifically some pharmaceuticals, selected pharmaceuticals, PFAS, microplastics, and antimicrobial resistant genes. Okay, these pollutants are under the consideration for future regulation in the European Union, and some of them already included in the legislation of another countries, in other parts of the world, like in California, for instance. And we believe that the results of the project will provide information about the fate of these non-regulated pollutants through the wastewater treatment process that will be available for future revisions of the legislation in Europe also, and in Spain. Actually, our project is aimed to produce high-quality reclaimed water to reduce the environmental impact of treated sewage discharge into a river in Spain. These are the two cases, and decrease freshwater usage for agricultural irrigation in Greece. Okay, this is the main application and the main cases that are considered in this project.
Thank you, Manuela. Next question is to Xavier. In the project LIFE BioGasNet, circularity is one of the bases of the technology used in this project. Can you explain what are the specific benefits in cost reduction in this treatment?
Oh, okay. So, okay, this technology operates without chemicals, and is is less energy intensive compared to other conventional tertiary wastewater treatment. So in this sense, there will be the operating costs at very low, and the footprint of the carbon footprint, or yes, energy consumption is the comparison with conventional tertiary wastewater treatments, because this is a tertiary wastewater treatment, is very favorable in this sense, with a reduction over 90% in energy consumption and more than 80% reduction in carbon footprint. We anticipate that.
Just because, Manuela, this technology don't use the physicochemical technology that are using currently for the treatment of wastewater as policemen.
Pardon me? Yeah, the application is, as I said before, is as a tertiary treatment. Okay, in the case of Spain, this will be implemented in a, well, actually is start implemented already in a municipal activated wastewater treatment plant close to Girona. Okay, and in Greece, they will be in operation in an experimental platform located in Antissa, in Lesbos Island, which include a flow anaerobic sludge planking reactor, which is also, by the way, producing also biogas, and also constructed wetlands in this case. So we have different, we can test different configurations and different scenarios to obtain reclaimed water for the irrigation of agricultural land, or to discharge this treated water safely to the river, to improve also ecological and chemical and biological quality, ecological quality in the river.
Thank you, Manuela. Xavier Gamisans, the same question to you. You can explain the specific benefits in cost reduction you have in your treatment?
Yes, thanks. Okay, let's see. The thing is that with our technology, we're trying to substitute, let's say, oxygen or air as electron acceptor in the oxidation of hydrogen sulfate by specific microorganisms. In our case, we are using nitrate or nitrite. This is why the project or the technology is based on this anoxic process. The main advantage is that we don't, we are not adding air, oxygen. This is diluting the biogas. We are not adding oxygen, which is a comburant. So this creates a dangerous mixture between methane and this comburant. But we add just nitrate or nitrite. The thing is that this nitrate or nitrite comes from, nitrogen wastes of different nature. For instance, in Cadiz, we used leachate from the South landfill, which is further nitrified to produce nitrate or nitrite. And then this nitrate or nitrite is introduced in our bioreactor, where hydrogen sulfide is oxidized to elemental sulfur, which is a valuable byproduct, and the nitrate or nitrite is reduced to nitrogen gas, which is just released to the atmosphere. Now in Athens, what we are doing there is using a different nitrogen source. There we are, collecting gases from a composting facility, which are rich in gaseous ammonia, and then we absorb this ammonia, we nitrify this ammonia to nitrate or nitrite. We both are good species for us. And then we send this nitrate and nitrite, this effluent, to our, in this case, a biotreating filter, where we are completely oxidizing hydrogen sulfide to produce sulfate. And then we mixture this sulfate with more ammonia absorbed from the composting facility to produce ammonia sulfate. This ammonia sulfate can also be sold as a fertilizer for the industry, for agricultural purposes. So basically, these are the most important benefits. We don't dilute biogas. We use an electron acceptor, which comes from a waste, and then also we produce byproducts which are valuable in the market.
From your answer, I have a couple of questions. One is, do you have identified a market to these products? I'm talking about elemental sulfur and also sulfur and ammonium, ammonium sulfate, sorry. Because I've read, I remind that in the past, when you take out phosphorus from wastewater, there was no market to this in the European Union, because it was forbidden to use in agriculture. I don't know if this is still the same. And the other question, just to answer both at the same time, for the formation of ammonium sulfate, do you need also to apply heat, or do you do just mixing both sulfate and ammonia?
Okay, thanks. That's a good question. In fact, we don't have at this point, we don't have a stakeholder that is ready to acquire these materials. But we know that from other projects that elemental sulfur can be, if we separate this elemental sulfur from biomass, this is another part of the project. So then we can just sell this metal sulfur to, for instance, this agricultural sector, but also to companies who prepare pigments because elemental sulfur is one of the raw materials in the process. We have contacted them with another project, so we know that they are ready to test our elemental sulfur to produce these pigments. And regarding the ammonia sulfate, the thing is that we are just creating at this point a very dilute concentration of ammonia sulfate in our systems, because remember that biogas is not, I mean, the concentration of H2S in biogas is not really that much. This means probably generally is perhaps under 100, 1000 ppms. So then it's the difficult part here is to concentrate this ammonia sulfate. So probably we should have to test other technologies, evaporation, whatever, to try to concentrate this. But at this point, we are just mixing the effluent of the biotreating filter, which is basically sulfate, with ammonia produced, ammonia absorbed from the composting facility, and we have this dilute solution. And yeah, probably previous to the market, we still have to work a little bit on the concentration of this byproduct.
Okay, thank you, Xavier. Now, in the project Life ANHIDRA, a question that you're proposing reusing water after reusing the industry. How is the quality of this water, and also if this use or the use of this water results in the same quality of the final product of the clothes and textiles you are producing?
I like that you make this question, because this was our premise and since the beginning of the development of the project. In fact, we started with the design and R&D phases focused on the requirements of the quality of regenerated water in order to reuse. And it's very important since the beginning of the project, ensure the quality of the end of the style product, final product, okay? And with this was our first premise requirement, and we developed all the technologies in place in the Life ANHIDRA with this objective. All the technologies developed based on ultrafiltration, ozone, or advanced oxidation, and all the variables and parameters in the machine was focused on these requirements of the final end product.
Drinking water. Thank you. Also, I have another question about sorry, the project, because I think that there's a cost reduction. So the benefits for the company that is going to have this new technology in the facilities, apart in the cost reduction in water use. There is another economic or commercial benefit due to the use of this green energy, green technology that reduces the use of water.
Yes, here for this question, I will answer you. First, very nice, and thanks the invitation to Life Eco Digestion for participating in this webinar. So related to the profitability or take advantage of the other wastes or other streams that are produced in the project and in the water treatment, we are mainly focusing on the recovering of the textile waste and fibers that are solved or contained into the waste water. As Victoria explained, the main process in which Life ANHIDRA is involved is about garment finishing and washing of garments. So during this washing process, a lot of particulate matter, a lot of fibers are released due to these washing processes, and we are able to collect this kind of fibers in different points of the system. because the system is equipped with different filtering systems. Also, you need to stop this kind of fibers prior to entering to the ozone generator and the ozone treatment. So we are going to study and to investigate which are the possibilities to reuse this kind of short fibers or this kind of even microfibers for different end applications. For example, to use this kind of wastes for acoustic insulation panels for building, for example, because they are already formed with this kind of short fibers that can be consolidated by mechanical or even by chemical or binder methods. Also, we are going to explore the possibilities to implement this kind of fibers or textile wastes in chemical recycling processes in order to valorize this kind of cellulose waste or cotton waste in order to produce new viscose fibers, new rayon fibers that are produced originally with wood pulp. And also thinking about the possibilities to recover some raw materials that are contained in water. The beginning of the project, for example, the exploring the possibilities to produce biogas or methane with this kind of wastes that are very rich on organic matter, very rich on cellulose, because the main composition of the wastewater is color, which is organic, also some detergents, tensioactives, maybe softeners, etc., and also the cellulose coming from cotton fibers. Now we are thinking to explore some synergies with another European project, which is coordinated by ITES, which is SimSites, which is focused on the different urban industrial symbiosis ecosites. And specifically in the area of Alicante, we are working with the wastewater treatment plant of Alcoy in order to valorize different water streams coming from the textile industry, coming from the cosmetic industry, mainly for producing also biogas, like some of the LIFE projects we are talking here. So maybe we explore in the second half of the LIFE ANHIDRA project the possibilities to reuse this kind of wastewater produced by your system, by LIFE ANHIDRA system, and to study which are the methanogenic performance of this kind of wastewater. So I think it could be nice.
Yeah, sounds interesting. I'm also working in life digestion in anaerobic digestion, and sounds nice to have this energy from other sources. we don't know. Okay. Thank you very much. I think we have to finish this roundtable because we are on time now to finish. I want to thank to all the panelists to be present here and for explaining their interesting projects. Thank you very much to all of them.